I'm working for Ericsson, so what I want to bring in the next few minutes is a little bit of a technology perspective from a radio standpoint when it comes to mmWave. So I will talk about uplink. You talk about superpower of mmWave. That's something I will cover. I also want to go back to what are the propagation characteristics of mmWaves. That's something I think is very important to always keep in mind. Line of sight, non-line of sight, outdoor, indoor. So I will spend some time on this. Before we get there, the fundamental of this industry is that there is more and more traffic being pumped into the network. From an Ericsson standpoint, our prediction is between now and 2028, the traffic will go up in the entire cellular industry. The data traffic will go up like 4 times. That means every year the traffic is increasing 30, 40%. And the traffic is not evenly distributed between all the sites. That's something that we know very well. So there are, you call that island of capacity, I call that hotspot or hot zone. And the point is that we have to cater for these very specific spots where we need to increase the capacity. The best way to handle this from a consumer standpoint is with mmWave. Why? Because the bandwidth, as we all discussed before in these different panels, is 10 times bigger than what we get in existing midband or existing FDD. And these are the fundamentals behind mmWave, besides, I would say, B2B use case that we see for the industry. A lot of my peers describe how mmWave is being used. I would like to spend a different angle into this. Besides the use case, I also want to reflect at how this is being deployed. So here you have 2 different, I would say, highlights, enhanced mobile broadband and then fixed wireless access from a consumer standpoint. But things are being deployed differently. So you've all seen the stadium, the big venue, and this is a use case that we see everywhere around the world when it comes to mmWave. A very controlled environment, typically line of sight, a very quote-unquote easy way to overload and manage capacity. In this case, this is dedicated indoor type of deployment. We also see in Japan, in Australia, reusing existing macro sites in dense urban, in the city, actually opportunistically reusing these sites on rooftop, adding mmWave and managing traffic in hotspot in the city in dense urban environment. That's another use case of mobile broadband. Then we have street furniture being used for mmWave. That's something we see, for instance, with Verizon in the US. So you're taking lamp posts, and you actually start using and embedding mmWave. That's an important way also to deploy for fixed wireless access and for enhanced mobile broadband. We see this in the US, in Australia. And then the last case, it's a little bit counterintuitive. You go into a rural environment, you can take a big macro site tower, and you put mmWave, fixed wireless access. Why? Because typically you have this pocket of capacity, community living there, and that's how you bring a massive amount of throughput into that specific community. In this case, macro cell site tower for fixed wireless access with mmWave. This is not just theory. Brian was talking about the Super Bowl. I have different statistics because we measure capacity differently. Again, Super Bowl is 57. The radio distribution per band, so you have the different color coding. You have FDD, typical FDD low band in purple, and you have in green, you have mid-band TDD, C-band, 2.5 or 3.5 or 2.6. And then you have mmWave in blue. What you see is what is deployed, and you see the traffic distribution per band. That's the overall amount of traffic. So 53% of the traffic was carried with mmWave during the Super Bowl. It's a very effective way of managing traffic during very, I would say, capacity demanding event. Now let's go back to the fundamental of propagation associated to mmWave. There are a lot of, I would say, different parameters you can take into account, but we try to bring an example of how do we see propagation when it comes to mmWave. Here we're using 28 gigahertz, and you have different categories. The toughest case is when you're indoor, and you're using an indoor CP. And there, when you're at, let's say, 300 meters from the cell site, so this is the radio cell sites and let's say the radius from the cell sites, we typically get 1.5 gigabit. Then you get an easier case. You get outdoor. Now you're non-line of sight, meaning the device cannot see the radios. In this case, At 500 meters, we see 1.3 gigabit. And then the perfect case is when you have full line of sight. So the device, the UE, is able to see the radio. In that case, at 500 meters, we can do 4 gigabit. And then we're stretching this. And that's typically the case for rural environment. We did a case with DNB in Malaysia. We actually did a world record. We push millimeter wave coverage in line of sight in a rural environment to 11.18 kilometers. So these are the, I would say, how we stretch ourselves, but also the typical coverage that we get in terms of sail radius associated to millimeter wave. That's one aspect. The second aspect that I think Juan was talking about, if only if I've had an extra superpower associated to uplink. And we have it. So, I mean, millimeter wave, we started in 2019. We have invested a lot of technology from a radio standpoint, from a chipset standpoint to actually improve millimeter wave. Here I'm looking at specifically uplink. In 2021, we're typically doing 300 meg. Last year, early in the year, we did 600 meg. You know, adding like more cell carriers. That is just like aggregating different cell carriers. Then later on last year, we also did some like dual connectivity between like C-band and millimeter wave. That's how we reach uplink 1 gigabit. This year on the booth, on the Ericsson booth, you can actually get and see live with an active radio on a device 2 gigabit uplink throughput for a device. And the way we do it is this time actually we're changing the TDD pattern. Typically the TDD pattern for millimeter wave is 75% downlink, 25% uplink. We actually like reversed it. So the frame, the pattern, sorry, for TDD in this case is 75% uplink, 25% downlink. And that's the way we reach 2 gigabit. Why does it matter? And you've heard my peer talking about this. This is how you enable advanced, disruptive use case, what you call superpower in industrial, when you want to carry a massive amount of video up, video surveillance, when you want to bring like specific media coverage and move up this traffic. And this is coming. This is something that you actually can get to see on the Ericsson booth. So this is a key enablers for bringing now the uplink enablers to bring this into the industry. Now I think Philippe reflected on the, oh, we lost the map. I don't know what happened. There is a map behind this. So you could guess east-west, and then in the middle you have Europe. We see a very mature ecosystem, both in the US and a scaling ecosystem happening in Asia. What we see is in India, you mentioned, there is a commitment or an intent to scale fixed wireless access millimeter wave up to 100 million visited home, and that is, I would say, in the making with Geo in India. From a consumer standpoint, when we look at our network throughout Europe, throughout Latin America, the penetration of millimeter wave device is below 1%. And that is kind of like a catch-22. If you don't have device penetration, there is no reason you will go and deploy millimeter wave in venues, in campus, in like rural environment. So this is a circle we have to break. We know we have to cater for like hotspot or islands of capacity. So we have to also start, I would say, seeding the market with millimeter wave enabled device so that we can actually cater for this capacity growth. And that's something that my peers have discussed before. This is my last slide. Is what we do is we do technology at Ericsson. And so we started developing and building, and the first one we shipped was in 2019, millimeter wave radios. Since then, from an Ericsson standpoint, we have shipped over 100,000 millimeter wave radios throughout the world. We have now our third generation of millimeter wave product. If you go on the, like you mentioned, between the Qualcomm and the Telefonica booth, you go in the middle, like when there is the walkway, like the elevated walkway, you just like look up, you will see two radios on both sides. This is the radio 5322 that you see here, and you can actually get to see it and then like play with the device on the different booth. This is live, this is actual traffic. What we have done in terms of, I would say, technology advancement, it's ease of deployability. And I think that's what Cellnex will come on stage and also discuss it, is that this system needs to be very easy to deploy. So we have integrated the baseband and the radio. We have also shrink the size over the generation, and we have also increased the amount of output power of the system. Why? Because that's how you improve the overall coverage of the system. So from the Ericsson standpoint, our message is the ecosystem is there, the technology is there. We have 4 years behind us of millimeter wave shipment. More than 100,000 radios have been shipped. We are absolutely committed from a vendor standpoint to keep on investing in millimeter wave from a radio standpoint. And so there are islands of, I would say, maturity. Let's scale this both for consumer and for enterprise. Thank you.